When considering the combination of various cathode materials and the anode, why is the expected range of 100 to 150 Wh/kg regarded as the best achievable performance for a fully developed Na-ion battery? How do the rate capabilities of Na-ion battery electrode materials impact their performance, and how do these rate capabilities relate to the energy density of the battery? What can we learn from the available rate capability information for electrode materials in Na-ion cells, and how is this information used to predict the overall behavior of the battery at different discharge rates? In terms of performance, how does the Na plus diffusion coefficient in the cathode and anode materials influence the rate capability of Na-ion batteries? And why is this diffusion coefficient an important factor to consider when comparing to other battery technologies? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How do the reported Na plus diffusion coefficients in these materials give us insight into how quickly sodium ions can move through the electrodes, and why does this movement matter in terms of charging and discharging rates? When discussing Na-ion batteries, how do these performance metrics compare to those of Li-ion batteries, and what makes Na-ion batteries potentially comparable in terms of rate capability? How might the performance of Na-ion batteries at different rates affect their practical applications, and how is this rate capability similar to that seen in Li-ion batteries? What exactly does good rate capability mean, and how is it measured? Can we expect Na-ion batteries to achieve performance that rivals Li-ion batteries in practical use cases, or are there any inherent limitations? What key differences exist between Na-ion and Li-ion batteries, and how do these differences manifest in real-world applications? When it comes to energy densities, how do Na-ion batteries measure up against their Li-ion counterparts in both laboratory and commercial settings? What are the potential benefits or drawbacks of Na-ion batteries in terms of cost, and how does this cost factor compare to that of Li-ion batteries? Are there any indications that Na-ion batteries can be produced at a lower cost than Li-ion batteries, and if so, what factors contribute to this? How do the costs of raw materials like sodium compare to those of lithium, and how does this influence the overall price of the batteries? Beyond energy density and cost, what other factors might influence the adoption of Na-ion batteries for specific applications such as electric vehicles or energy storage? How do consumer preferences and overall market acceptance of Na-ion batteries compare to the already widespread use of Li-ion technology? What barriers or challenges might Na-ion batteries face in achieving consumer acceptance, and how can these challenges be overcome?